A new office residential building just opened in Lagrangeville. Brownie points if you see what they did there. And the contractor is monitoring the water use. So for the most part, water is used by the office between the hours of 7 a.m. and 7 p.m. and the residential section between 12 a.m. and 9 a.m. or 3 p.m. and 12 a.m. including the endpoint times. So, part A, create a compound inequality written in interval notation that represents the hours that both sections are using water at the same time. Interesting. So, graph the solution on the number line given. Oh boy. Assume that 12 a.m. corresponds to 0. This is important information here. 12 a.m. corresponds to 0, and a time such as 3 p.m. corresponds to 15. And here's a piece of advice that I think is good advice. As a start, it might help to graph each individual section of water use and see where they overlap. All right. This blue highlighted spot is problematic, right? We're going to have to change this number line. I think they're trying to get us to think in 24-hour time, which I do not really feel like doing. So since 12 a.m. corresponds to 0, then what I'm going to do is I'm going to call it 12 a.m. Right? And if this goes up in intervals of 6, then the next one would be, let's see, 6 a.m., right? 6 a.m. Then this one in the middle, well, that would be 12 hours later, 12 p.m., right? This one is going to be 6 p.m., okay? And the last one, 24 hours. 24 hours after 12 a.m. gives you 12 p.m. So we've got a whole day graphed out here. And why did they bother telling us something like 3 p.m. corresponds to 15? Well, probably because 3 p.m. is where 15 would have been, or where it used to have been, right? You've got your 3 there, your 3 p.m. Between 6 a.m. and 12 a.m. we have our 6 p.m. and 12 p.m. we have our 9 p.m. Between 6 p.m. and 12 p.m. a.m. and, oh boy. Between 6 a.m. and 12 p.m. we have our 9 a.m. I'll just fill that in, p.m., p.m., and then between 12 and 6 we've got 3 a.m. Let's hope and pray that makes things a lot easier for us, and I think it will. Now let's start taking their advice. So it might help to graph each individual section's water use and see where they overlap. Okay, let's talk about the office. Office is using water between the hours of 7 a.m. and 7 p.m. Okay, 7 should be right about there. 7 a.m., 7 p.m., right about there. So what I'm going to do is I'm going to draw a nice little line here to represent when the office is using water. I've closed off the endpoints because they did mention that these times are including the endpoints. Okay, so I'm not going to leave them as open dots, I'm going to leave them as closed dots. Now let's talk about the residential section. They're using water between 12 a.m. and 9 a.m., okay? So that's going to be here, 12 a.m. all the way to, let's be careful here, 9 a.m. Let's close off those dots and draw us a line. And there's another region of time where they are operating their water appliances, and that's between 3 p.m. and 12 a.m. So 3 p.m., check, and 12 a.m., check. Let's close off the endpoints there and draw a line. So now let's think about what we're trying to look for here. We're looking for where they overlap. The times in which both the office and the residential section are using their water, and that looks to be this region right here. Starting at 7 a.m., ending at 9 a.m., before it's all office, but then starting up again at 3 p.m., and ending at 7 p.m. All right, so now let's be very mathy and let's write an inequality that represents this thing, okay? We are looking for two regions of time, all right? So the method for this goes like this. We're talking about time, t, such that, okay, we're going to put some conditions on it. T is going to be between a couple of things, all right? Between 7 a.m. and between 9 a.m. But there's another condition, okay? I'm going to separate it with a comma because we have to talk about this region too. So we're looking for times between, let's see, 3 p.m. and 7 p.m. And sometimes in math notation we would close off a statement like that with little curly brackets like that. And I would say we're done, and we're close to being done with part A, but it's not quite there, all right? Conventionally, you're going to want to convert these times, these 12-hour timescale times, back into numbers. See, remember, that was 0, okay? And let's see, that was 6, and that was 12, and that one was 18, and that one was 24, of course, right? So let's think about our endpoints here. This one, well, the next one after that was 7, right? 7 a.m. stands for 7, so that's okay. And the 9 a.m., that was just in the 9 spot. Now the 3 p.m., well, be careful here. That was 3 hours after 12 p.m., which on the old graph that I erased was number 15. And this is going to go, oh, not to 18, but actually to 19. 7 p.m. is just after 6 p.m., just after 18 hours, after 12 a.m., 9 hours. So really, the better way to write this is like so. T, such that instead of 7 a.m., I'm just going to put 7 hours. It's going to go to 9 a.m., which is 9 hours. Separate it, new condition. Now I'm going to use the number 15. Put time between 15 and 19. And that, my friends, is going to be the answer to part A. Now let's think about tackling part B. If the water in the building cannot sustain more than 4 hours of use from both parties at the same time, will there be a period of the day that cold water will start to be produced? Well, when you run out of hot water, you tend to get cold water, all right? So let's just think about, is there a time when there is too much water being consumed, right? In order for that to happen, you would need a 4-hour interval where both the residential section and the office section are using water. And let's point out here that, let me try and get another color here. How about that one? Let's point out that this region here, from 7 a.m. to 9 p.m., or between the hours of 7 and 9, however you want to think about it, it's a 2-hour span. And between 3 p.m. and 7 p.m., or between the hours of 15 and 19, it's a 3-hour span. Which means there are no 4-hour spans where both parties are using water, okay? So the answer is no, all right? And the explanation for that is that the shared water usage times, I guess you could say it like this, do not exceed 4 hours. And your proof of that is pretty much right there. It only goes between 7 and 9 and 15 and 19. 2 hours and 3 hours.